Welcome back to Context Window. This explainer covers 12 high-level things a Gen AI engineer should know about. Now, the concepts covered here are high-level. We are planning to cover them in depth in future explainers, but let's get started. If you're a software engineer looking to pivot into AI roles, you should know the landscape is undergoing a massive seismic shift right now. To succeed, you really need a dual competence, a rock-solid grasp of core back-end principles, combined with a deep understanding of this entirely new probabilistic reasoning paradigm.
To help you successfully pivot into AI, we're going to map these 12 pillars across 5 main sections: foundations and core systems, engineering autonomous agents, memory and multi-agent workflows, deployment and real-world execution, and finally, evaluation, safety, and growth.
Section 1. Foundations and Core Systems, Core Concepts.
Let's kick things off with Pillar 1, AI agents. You know, a lot of folks casually mix up chatbots and agents, but architecturally, they are worlds apart. While a chatbot just passively answers prompts with a linear text-in, text-out response, AI agents are incredibly proactive. They actually use a reason and act pattern to dynamically figure out their own execution path. When you hand an agent a complex goal, it doesn't just respond, it plans, it executes loops, and it handles errors totally autonomously.
But to actually build those autonomous agents, Pillar 2 is a great reminder that your existing back-end skills are absolutely vital connective tissue. You really can't skip the basics here. We are talking about asynchronous Python to handle high-latency API calls, understanding RESTful APIs, and having incredibly strict JSON validation, because LLMs natively output raw text. Structuring that text into exact JSON schemas, using libraries like Pydantic, is literally what keeps your entire application from crashing. And of course, modular object-oriented programming is just as important here to cleanly encapsulate your agent's states.
Moving right along to Pillar 3, understanding LLMs. The crucial point to grasp here is knowing exactly how to manage token budgets so you avoid hitting those context window limits where the model just forgets information. You also have to make some big architectural decisions, like balancing hosted APIs versus open source models. Hosted APIs like OpenAI give you a really low setup cost, but you are subject to third-party data privacy rules. On the flip side, open source models like Llama require some heavy, expensive GPU infrastructure up front, but they give you absolute data privacy and practically unlimited customization.
Section 2. Engineering Autonomous Agents, Building the Loop.
Pillar 4 is prompt engineering. And hey, forget about that vague idea of prompt whispering. This is empirical, programmatic instruction. We use system prompts as the absolute operating rules for the agent, tightly dictating its persona and its constraints. On top of that, we use techniques like chain-of-thought prompting. By forcing the model to explicitly think step by step, we actually expose its underlying reasoning chain. This is a game changer because it drastically reduces logic errors and stops those notorious model hallucinations.
Which brings us nicely to Pillar 5, Agent Architecture. Instead of one-off interactions, autonomous agents rely on a continuous event-driven loop. The flow basically goes like this. The agent receives an input. It reasons about its current state. It decides to take an action using an external tool, and then it observes the output. And if the overarching goal isn't met, the loop just runs again. Maintaining the state and memory of this continuous loop is honestly one of the major engineering challenges you'll face.
And speaking of tools for Pillar 6, tool calling and integrations. Listen, you absolutely must use structured JSON function calling to interact with external APIs. Giving an LLM direct, raw SQL access to your database is literally like leaving the bank vault wide open. It's a catastrophic security vulnerability. Doing that opens you right up to SQL injection via prompt injection. So always expose highly structured, tightly bounded tools to your agents.
Section 3. Memory and Multi-Agent Workflows, Scaling Workflows.
Pillar 7 covers memory and context systems through a really elegant process called Retrieval Augmented Generation, or RAG. It's basically how we give models long-term memory. Step 1 is ingestion. We embed your proprietary documents into mathematical vectors and store them in vector databases. Step 2 is retrieval. We use similarity search to pull the most relevant text chunks based on whatever the user queried. And finally, step 3 is generation. We inject that retrieved context directly into the prompt. This forces the LLM to generate grounded, highly accurate answers without needing to be entirely retrained.
Now, when tasks span multiple operational domains, a single agent is going to break down. That's where Pillar 8 comes in, multi-agent systems, which often utilize a supervisor-worker topology. Basically, a supervisor agent analyzes a massive enterprise goal, maps out a dependency graph, and then delegates subtasks to specialized worker agents in a collaborative pipeline. Think of it like having a coder agent and a tester agent working back to back. But a quick warning here, These systems require heavy execution telemetry and hard limits to prevent agents from getting stuck in infinite, really expensive communication loops.
Section 4, Deployment and Real-World Execution, Production AI.
For Pillar 9, backend and deployment, your stack is going to rely heavily on highly concurrent, asynchronous frameworks like FastAPI or Node.js. And because AI codebases have notoriously complex dependency trees and C++ bindings, strict Docker containerization is just absolutely mandatory. When you deploy on cloud services like AWS or Google Cloud, you're going to face a brand new challenge. Traditional application logs completely fail for probabilistic AI. So you have to use specialized tracing tools like LinkSmith or Phoenix to track exact prompt inputs, the internal reasoning chains, and of course, your token costs.
To truly prove your mastery for Pillar 10, real-world AI agent projects, you need to ship some concrete applications. Try building one of these 4 foundational projects. You could build an AI coding assistant that natively reads GitHub tickets, writes the code, and submits pull requests. Or maybe construct a research agent that synthesizes massive white papers. You could also try a customer support agent tied directly to an ERP database, or even an AI scheduling assistant. Building any of these proves you can successfully balance speed, cost, and system accuracy in the real world.
Section 5, Evaluation, Safety, and Growth, Closing the Gap. Pillar 11 tackles evaluation. And heads up, there is a massive shift in testing mindsets here. You literally can't just use standard assertion blocks anymore because an LLM is never going to give you the exact same string twice. Instead, you've got to use statistical scoring frameworks like Ragos or DeepEval. These run metric scoreboards to scientifically measure your system's relevance, its faithfulness to the context, and its overall semantic correctness. It's a whole new ballgame.
Also nestled right inside Pillar 11 is safety. For high-risk operations, think executing financial transfers or sending external client emails, you must build human-in-the-loop approval screens, which forces the agent to pause and wait for a human to actually click approve. Additionally, you need proxy firewalls like LlamaGuard, sitting securely between the user and the model. These are crucial to stop prompt injections and prevent personally identifiable information from leaking dead in their tracks. All of this intense learning culminates in Pillar 12, Career Growth. General software engineering is rapidly evolving, and the market right now highly values specialized roles like the agentic architect. By combining your deep back-end engineering chops with these new probabilistic concepts, you can seriously accelerate your career growth. Contributing to open-source orchestration libraries, building your own AI micro-SaaS to solve legacy B2B inefficiencies, and just committing to continuous learning will absolutely keep you at the very bleeding edge of this industry. So, you now know the 12 pillars of Gen AI engineering, but the real question is, which probabilistic system will you build first? That's all for now. If you like this content, please hit that like button. If you'd like to know more about topics like this, please subscribe to this channel. And if you find this explainer will be useful for your friends, go ahead and share with them. Good luck!